Alright guys, let's try this out. Okay, so bear with me because it's my first time and I hate my voice and this is going to be awkward. But here is your learning target. I can factor easy quadratics, and this learning target is brought to you by Amos, my son. And this is Allie over here. That's my niece. They're both out of school and daycare, so we needed something to do. So we are going to review factoring easy quadratics, and then hopefully this gets back refreshed into your head, and we'll see how it goes. Alright. Okay, so here's the first one. If you'll notice, there is only an understood 1 in front of x squared. So these are our shortcut factoring problems. So what we need to do is find two numbers that multiply to give us the last number, 7, and then two numbers that add to give us the middle number right here, 8. So sometimes that takes a little longer for people to figure out, but the only two numbers that multiply to give you 7 and add to give you 8 are 1 and 7. So then if you'll remember, that is what you write in your parentheses. So your answer is going to be x plus 1 and x plus 7. And that is how you factor that easy quadratic. Alright, so next, same thing. We need to find two numbers that multiply to give us the last number, 10. And then we need to find two numbers that add to give us the middle number, negative 11. So if you think about that, you know the two numbers have to both be negative because they have to multiply to give you a positive, and they have to add to give you negative, so they both have to be negative. The only two numbers that are going to work are negative 1 and negative 10. And so that is what we write in our parentheses. So our answer becomes x minus 1 and x minus 10. Alright. So, very similar, same thing again. Two numbers that multiply to give us the last number, negative 90, but we want them to add to give us the middle number. So remember, if you don't see a number, it's an understood 1. So you know if they have to multiply to give you negative but add to give you positive, one of them has to be negative, one of them has to be positive, and then also the bigger number is going to be your positive one. So my two answers are going to be a positive 10 and a negative 9. Alright, and then my answer is going to be x plus 10 and x minus 9. And if you ever flip those numbers around, that's the same thing. That's the same thing if your answer was an x minus 9 in front and an x plus 10 at the end. So it's really up to you how you write it. Alright, so here's the next one. Same thing again. It's pretty redundant, I know. Two numbers that multiply to give me the last number, negative 12. But they add to give me the middle number, positive 4. We know the two numbers, one of them is going to be positive, one of them is going to be negative. The bigger one's going to be positive since I'm trying to add to get a positive 4. So those two numbers are 6 and negative 2. And then my answer would be x plus 6, x minus 2. Alright, so here's another example. Two numbers that add to give me the last number, 9. Two numbers that, I think I just said add, sorry. Two numbers that multiply to give me 9. Two numbers that add to give me negative 10. So you know the two numbers need to both be negative, and those only are negative 1 and negative 9. So my answer is x minus 1. X minus 9. Okay, so this one works the same way. It's actually a perfect square trinomial, and I just know that automatically because if you look at that last number, it's a perfect square. So the square root of 64 is 8, and then 8 plus 8 is 16, which is how I know in my head automatically that's a perfect square, but if you don't, it's fine. Just find two numbers that multiply to give you 64, but they add to give you a 16. Just kidding, I said the two numbers. It's 8 and 8. Okay, so my answer would be x plus 8 and x plus 8. That's why it's a perfect square trinomial, because it's the same square. So this is that case where you can write x plus 8 and then square it at the end. Alright, so another example. You need two numbers that multiply to give me 24, but add to give me -4. Two numbers are... Yeah, so this is one of those tricky ones where you can't actually think of the two numbers. So this one is not factorable. And we are going to have some like that on the next unit, so that's why I wanted to make sure you remember how to do these. Alright, so I want you to try these four. You can hit the pause button if you need to. So I'll start talking, or you can like listen to me explain it and then try them, whatever you want to do. So if you want to hit the pause button, I'm going to let you do it in 1, 2, 3. Okay. So these are the same things. I'm just going to, in blue, I'm going to circle the numbers that you want to multiply to get. And then in red, I'm going to circle the numbers that you want to add to get. Alright, and I'm just going to do the shortcut method. So I'm trying to think of two numbers that multiply to give me 40, but add to give me -13. Those two numbers are -5, -8. So if you got that right, yay! Alright, next one. I want two numbers that multiply to give me 18, but add to give me 11. The only two numbers are +2 and a +9. So my answer is x plus 2 and x plus 9. If you got that right, yay! If not, it's okay. Alright, number 3. So this one's a little bit trickier. Two numbers that multiply to give me -56, add to give me -1. Those numbers are -8 and +7. And then the last one trips people up a lot. I need two numbers that multiply to give me 6, but add to give me -5. Those numbers are -2 and -3. Okay, so if you got them all right, congratulations. If not, try and find your mistake. Go back and watch the video. Do what you need to do. If you're ready to move on, here we go. Okay, so these are actually disguised. They don't look like they're that shortcut method, but they actually are if you take out the GCF. So wanted to make sure that you guys remember how to do this. So you're looking at all three terms, and when I say terms, you're just really focusing on the numbers. What's the biggest number that they're all three divisible by? And the biggest number that they're all three divisible by is, drum roll, 2. Okay. So I'm going to take out a 2 from each one of these. And remember, when I take out a 2, it's really like I'm dividing each term by 2. So it's kind of like this. So I took out a 2 GCF. And then what I'm doing is I'm dividing each term by this. Okay. So I got x squared plus 3x minus -54. Alright, and then I'm doing the same thing as I have been doing. I'm finding two numbers that multiply to give me that -54. And then two numbers that add to give me the +3. Alright, so if you need to think about that for a minute, 9 and -6. So my answer is x plus 9. Oh, I made that ugly, sorry. And x minus 6, and then don't forget that 2 that we took out at the very beginning, that is a part of your answer. Alright, same thing as the last one. We're looking at all three terms. What's the biggest number that they're all three divisible by? It's 5. So I'm going to take out a 5, which means I'm going to divide each term by 5. So 5x squared divided by 5 is x squared. 10x divided by 5 is 2x. And 20 divided by 5 is 4. So there we go. So now it's the same as it always has been. I'm looking for two numbers that multiply to give me that last number 4. But they have to add to give me the middle number 2. And this one's pretty easy. It's just 2 and 2. Just kidding. Just kidding. Oh, I tricked myself. Good job, Miss Slate. Okay, this one is one of those that you can't factor. So that's embarrassing. Here's the final answer. You can't factor any further, so it's just that. Alright, good. Well, you should feel like you're back at school with me making mistakes. Alright. Okay, so next one. Let's see if I can try not to screw this one up. Look at all three terms. They're all divisible by a 2. So we're going to take out a 2. So we're going to take out a 2. We're left with x squared plus 11x plus 30. Then let's see if I can get this one right. Two numbers that multiply to give me 30. Two numbers that add to give me 11. So I got a 6 and a 5. And then I'm going to write those in my parentheses. X plus 6. X plus 5. And then don't forget that you took out a 2 at the very beginning, so that is a part of your answer. Okay, so now I want you to try these 3 problems. You can push the pause button and then continue when you're ready to go on, or you can just watch me do them, whatever you want to do. But if you want to hit the pause, hit it in 1, 2, 3. Oh, okay. You know that I have trouble waiting. Okay. So for this first one, we can take out a 5 for its GCF, and then we'd be left with x squared minus 6x plus 8. So then I'm looking for two numbers that multiply to give me 8, but add to give me negative 6. So an x minus 2 and an x minus 4. That's my answer for number 1. If you got it right, yay! Alright, then number 2. A 2 is the GCF that you could take out. So I'm going to take out a 2 and show you what's left. I got this. So then I'm looking for two numbers that multiply to give me negative 2, but add to give me 1. So the only thing I can think of is a positive 2 and a negative 1. Yay! Alright, and then the last one, a 4 is the GCF I can take out. Go ahead and do that. Here's what's left. It's very similar to the last one, except kind of flipped around. So I'm looking for two numbers that multiply to give me negative 2, but add to give me negative 1. So that is x minus 2, x plus 1. So here are the final answers. Just make sure that any GCF you take out, you're including in your final answer. Okay, cool. Oh, and that's the end of the video. So, if you feel like you need some more help, I'm going to put some worksheets online that you can do. You can ask me for any help, but the end. Thanks, coronavirus. You're making class so fun. Alright, I'll see you guys later. Bye.